Let's now take a look at the use of ampersands and asterisks when it comes to pointers. It can be very confusing when there is like an asterisk used in an expression and one of the variables is the pointer variable. Does it multiply? Does it infer, get the contents of an address that is in the pointer? Which one? So what we have on the screen here is I have an example, some code that I already populated within the main function. And what we are going to do is uncomment the lines of code and run it recursively, run this code again and again to kind of learn more about how to use the asterisk and the ampersand symbol when it comes to pointers. All right, so what you have on the right here is the terminal. So if you're trying with me or if you're trying alongside, uh, go to this the burger sign here, then go to terminal and then click new terminal. The terminal shows up here. I want it to be in our as a editor on the side, so I'm going to drag and drop it, and so we have terminal here. Now what I'm going to do is remove the old a.out file. So that file is gone. It disappeared from here. Okay, so now let's go ahead and talk about this code. So I have few integers and one pointer and one character. So let me talk to that. So this is an integer and this is an integer, right? So I and x are integer. X is not having any value right now. I, however, is hex AA, and the reason to this is like a nice, alternating patterns of zeros and ones, right? So this is A, so hex A, right? So C here is a character, so it's 1 byte, all right, 1 byte, and then it's 3. Right? The number saved there is 3, and uh, CPTR CPTR is defined to be a character pointer, right? And it is also not assigned to anything right now at this point. And then with that, I'm just going to go ahead and print the current, values, so to speak, of these variables. So let me then kind of go ahead and compile the code. So gcc main.c and hit return. We have the a.out file created here, which means now we can execute a.out, and let me go ahead and do that, a.out, and then we see some values being printed. Okay, so what is it? So the address of C is, so recall that somewhere in the memory there would be C. So the address of that C is something something 977, right? This is the address. And then the other thing is that X is having some value 21858, but we didn't assign it anything. So this is a garbage value, and that's why I have printed garbage keyword here. Similarly, if we move ahead, CPTR has this value, but we did not assign it anything. So CPTR is also garbage, meaning whatever location CPTR is at, right? So there is some random number, and that random number happens to be this. Now, if you see, I printed CPTR twice. There's a reason for that. One is I wanted to print it like a pointer, and the second, I wanted to print it like a number, unsigned, like long unsigned int. The reason to this is sometimes CPTR shows up as nil, which is printf's way of printing a zero or null pointer. And what I wanted to do was wanted to show you by printing it as a number that indeed it is 0. In this case, it happened to be some random number, so both the prints are same. But had it been 0, had CPTR been 0, we would have seen nil and 0. And you might actually see this in your run. So which is perfectly all right. Okay, so with that, let's just uncomment this piece of code here, right? And what is happening? So what I have here is x equaling I ANDed with C. So the AND here serves as the logical AND operation. So this is something like so, right? So we have the I here, C here, and the X here. Now, why does it serve as an logical AND operation and not the address of C? Because, well, I address of C makes no sense. Like, what operation is this, right? That is number one. Second thing is that on both sides, we have integers. Okay, one is an int, the other is a char, but char behind the scene is an int of 1 byte, right? So what the compiler would do is extend this to assume it to be like 4 byte, or the CPU does it during a calculation, kind of upgrades the type from character to int, and then you can add, you can AND both the ints to give an int answer. All right, so let's go ahead and execute this and see what comes out. So we will recompile our file gcc main.c, compiles well, and then after that we run a dot out. Now, if you see, when we are printing the value of x, we see a 2. And why do we see a 2? So I was hex AA, and C was 3, and then we have X here. Now recall that this is what AA is, and then so this is C, this is I, this is binary representation of 3, and so when you AND all of these together, all of these are 0. This is a 0, this is a 1, which stands for 2, right? So this here is serving as the logical AND operation, bitwise ANDing, right? That is what it is. Now it gets interesting. Let's move on and kind of uncomment this part of the code here. And what I'll do is I'll comment this back just so that, this is out of our way. Now what you see happening here is we are assigning CPTR to be address of C. So CPTR should be some number like so. And remember that, these numbers can change across the runs, which is natural, but whatever is the address of C, that should be the CPTR value for this run. Okay. And what we are doing now here is we are saying, hey, we want to repeat this AND operation, but with I and CPTR now, right? So X. And the question is, will this succeed? And then if you see here, we are doing something similar, which is we say, okay, I want this I, but then now try and AND it with the address of C, right? And here's X, right? So let's see what happens. And just to do this piecewise, I'm going to comment this part out. And then let's just try and run this much piece of code, right? So gcc main.c, and it doesn't work. So something happened here. What does it say? It says invalid operands to the binary AND. So AND operation, you're saying, hey, on one side you give an int, and on the other side you're giving like a character pointer, right? So it says that, hey, at this point I do not know how to process this. So in that sense, what should be clear is you cannot AND an integer with a pointer, right? That is not allowed. But can we AND pointer with a pointer? That you can try on the side. But at least an integer and a pointer, you cannot AND those together. Okay, so let's move on. This did not work for us, so this piece of code won't compile. So let me comment this. And then let me go ahead and see what happens if I try this, which is, okay, this is the AND operation now, right? Let me just, yeah. So this is the AND operation. And then we are saying, hey, could you now AND an integer with an address of C? Let's see how that works out. So now let me go ahead and compile GCC again, but main.c again, and it still gives me an error. And the error is, again, invalid operands, we have an int, and on the other side, we have a character pointer, right? And now it should be clear that the first time in an expression it sees an ampersand, right, with multiple operands involved, it will think that this is a logical ANDing. And the next time it sees an AND in front of the variable, it will figure that we're asking for the address, right? Look, the difference between this example right here and this example right here. Okay, let me just get rid of a few things, which is, yeah. So the difference between these two is an extra and in between. So when it saw this ampersand, it figured that, hey, we're talking about the ANDing operation. When it figured this AND, it figured there is an ANDing operation, but the next ampersand here, that conveys that now we are talking about address of the variable, right? So that is kind of, just be mindful when you use the the ampersand symbol around a variable. It may mean that we are trying to infer the address of the variable if it's used more than once in a row. Like if you have two ampersands back to back, be wary as to what the second might imply, right? So that was like the point I was trying to drive home. Hopefully you're convinced. And I encourage you to, go ahead and try out, multiple such examples. Try using these in arbitrary sense and see what comes out. Okay, now let's then move on. And what I'm going to do is, for this, we need C to be uncommented. No, okay, everything's great here. Perfect. So what is this example? So we are setting I to all Fs now. Well, all ones, which is FF. So this is what I is, and all of these are zeros. So recall I would be 32-bit wide, just because it's an int, and an int is let me just, yeah, and an int essentially is 4 bytes. That's why 32 bits. Okay, so then let's go down here, and we are doing something along the same lines of what we were attempting previously, except this time there is this int within the parenthesis, and the ampersand C is put in parenthesis, right? These parentheses are not necessary. We can rerun the example, removing that. But what's happening here is, recall that the problem in this error was that to the ANDing operation, there was an int and a char star, or a pointer of the type character, was provided, and it didn't know how to AND those. But what we are saying now is, hey, infer the AND operation, but then before you consume this entity here, which is char star type, which is a pointer type, what we want you to do is, hey, just treat this as an integer. Never mind that it is a char star or character pointer. Treat that as an integer. And an interesting thing happens, which is, in this case, my claim is that the code will compile and run. So gcc main.c, it gives us a warning that we are trying to kind of cast from a pointer to an integer, which is not usually the right thing to do. But yeah, it does compile, right? And so if we now go ahead and run it, yeah, we do see 67, right? And this is interesting. Again, why 67? So if you see, this is the address of C, which is having a 67 as the lower byte, right? And if you see CPTR here, okay, that is pointing to, okay, we haven't even assigned it, so never mind. You see that we don't have CPTR assigned anywhere here, so ignore CPTR, ignore X as well. The value of X is set here to 67 because I was all ones, and the two, or let me just do it this way. So I was hex ff, and we ANDed that with a lot of this entire address, and only the last one byte would be ANDed and retained. So we have the answer as 67. Point being that the ANDing operation worked. And now what I'm going to do is just make that one modification to drive the point home, which is this is not required, right? The parenthesis is not required. So let me just run this example. Again, let's compile, compiles, and then it just gives us a warning that, hey, we are trying to upgrade a pointer to an integer or changing the type of it. And we see something similar. Again, in this case, the answer is different because the address of C is different, right? But essentially, the last byte is retained. And to retain the last byte, that was the point of having hex ff. That is why I was keeping I set to hex ff. Okay, so hopefully this convinces you as to, how you can use ampersands. Of course, to get to like a very fluent understanding of when to and when not to use ampersand, you'll need to practice a little more. I suppose when we explore online repositories that are written in the C language, we can talk a lot about stars and ampersands there also, asterisk and ampersand. Okay, so what is happening here? We are assigning CPTR to the address of C here. And let me then go ahead and demonstrate how that works. Right. So in this case then, so address of, okay, these are the initial prints, right? The ones on the top. Okay, let me just show that quickly. These prints when we hadn't, assigned the CPTR. And what we are now doing is checking this line, which is CPTR is this value, and the address of C is this value. So both are same, right? So CPTR is then the address of C. It's holding the address of C. That's the idea, which we had also seen earlier, just reiterating. Okay, then let's go ahead and try to do some more fun stuff. So what's happening? Now let's focus our attention on the use of asterisks or stars. So if you look at this example, what I'm now saying is, hey, I want X to equate a multiplication of I into CPTR. But then in the previous section, we had seen that if we do star CPTR, it actually means, hey, CPTR is somewhere, then the C is somewhere, and CPTR was pointing to C, let's say an address of A or ABCD. So ABCD. So what star CPTR meant in that context was, okay, take the address ABCD, go to that location and fetch the contents within it. And we had A here. That's what star CPTR or C underscore PTR from the previous time meant, right? And this we formally call dereferencing. To dereference a pointer means to read the address that the pointer is holding and then read the data within it. So then the question is, if I use CPTR here, would it mean this, the dereferencing operation, or does it mean multiply? Which one? So again, much like the ampersand case, a single star is interpreted as a multiplication operation first, right? When used in an expression or when used in like a mathematical term, right? I star, let's say CPTR. So this is seen as multiplication first. So to prove my point, let's then go ahead and compile this. Okay, and then there's an error. And what does the error say? It says, okay, the binary the binary operation, it has invalid operands. So one of them is an int, another one is a char star, and I don't know how to multiply those together. It's like, okay, much like the previous time, we had the same issue with the ampersand symbol. So then you cannot multiply an integer with a pointer type, right? So let's get rid of this. Now I'll comment this out. Let me comment this out, and let me uncomment these two lines here. Again, same story, right? And actually, let me also uncomment this, right? So what we are doing here, we don't need this anymore. Let's get rid of that. Okay. So what we are doing here then is we are again assigning CPTR the address of C, printing that out to ensure that both of them are same. Then we set I to 2, and here we use double star, right? So we say X equals to I double star CPTR. Now, if you can guess what would happen here, the first one would be taken as the multiply operation, and the second one would be treated as a dereference operation. Right? So let's go ahead and try that. So let me compile. Works fine, so no problem there. And when I do a.out, you see that I CPTR star multiply answer is 6. Why is it 6? So I is 2, and remember C was 3. So if I were to go back up here, C is 3. So 3 into 2 is 6. And so what this should convince you, uh, what this should convince you about is that the first star is a multiply and the second one is seen as the dereference, meaning whatever address CPTR is holding, go to that and read the value from there, and that value is 3, right? So that is what this is conveying. All right, the last one is the same thing, the same exact thing with parentheses put around here. Right, so if you see there are parentheses put around the star CPTR, and that's just from the readability standpoint. Effectively, this and this are exactly the same thing. It's just that the star here, it becomes very hard to read that we are doing a dereference operation, whereas here it kind of is nicely contained within the parenthesis. So let me then go ahead, compile again, run again, and if you see, we have exactly the same answer. Right? And so with this, we kind of have seen variations of, the use of asterisks and the use of ampersand in expressions and mathematical, expressions and assignments. In the exercise or in the assignments, you'll see few more variants of this, and hopefully that gives you enough practice to, understand how to look at a statement with stars.